Have you ever wondered how your search engine seems to just read your mind? Well, today, we're going to pull back the curtain on the technology that makes that happen. It's called embeddings. And really, it's the secret sauce that allows AI to understand what we mean, not just the words we type. So let's dive in.
I'm sure you've seen this happen, right? You type in something like Dr. Pay Growth, and the very first result is an article titled Annual Physician Compensation Trends. And get this, not a single word from your search is in that title. So how on earth does that work? It feels a little bit like magic. And honestly, the reality isn't that far off.
To really get what's so special about this new kind of search, you first have to understand the old problem. For decades, search was basically just the game of matching keywords. If you didn't use the exact right words, you were pretty much out of luck.
See, the old way was super literal. If you searched for fast car, it was just looking for documents with the words fast and car. It would just completely whiff on an article about the quickest automobile. But the new way, the AI-powered way, is all about grasping the concept, the actual idea behind your words.
So, what's the fix for this old search problem? Well, the solution is a truly revolutionary idea. It's almost like we've created a kind of magical map of meaning itself.
And this map is built using something called an embedding. Now, at its core, an embedding is just a list of numbers, a vector. Think of it like a coordinate on a map. But it's not a random list of numbers, oh no. It is very carefully designed to capture the conceptual meaning of that piece of text.
So just imagine a giant, multi-dimensional map of all of language. Every word, every sentence, every idea gets its own specific location. King is plotted right near queen. Dr. Pay is plotted very, very close to physician compensation. The distance between any 2 points on this map tells us exactly how related those two ideas are.
You know, a really cool way to think about this comes from Indian mythology. An embedding-powered search is like an astra, one of those celestial weapons. You summon it with a mantra, right? That's your search query. But the astra doesn't just look for a name. It seeks the essence of its target. It understands your intent, not just your keywords.
All right, so we've got this incredible map of meaning, but, just like any map, there isn't just one way to use it. It really depends on what you're looking for. And this means you've got to choose the right search strategy.
This brings us to a really key distinction, what we call dense versus sparse search. Now, sparse search is our old friend, keyword matching. In our analogy, it's like telling the Astra to find the warrior with blue skin, a mace, and a peacock feather. It's incredibly precise. Perfect for when you need to find exact terms. But dense search, that's about the essence. It's like asking the Astra to find the greatest warrior. And that's where the real power of embeddings is, in understanding meaning and nuance.
But there's a catch. Dense search can be pretty slow when you have billions of documents to sift through. So in the real world, engineers use this really clever two-stage process. First, you have a fast scout, a bi-encoder. Think of it like Hanuman, just quickly flying over the entire battlefield to give you a short list of promising spots. It's fast, but maybe not perfectly precise. And then you bring in the expert, the cross-encoder. This is like Rama, who carefully examines every single item on that shortlist against your query to find the absolute perfect match. This recall then re-rank strategy gives you the best of both worlds, speed and accuracy.
So, we have this magical map. But how do engineers actually make sure it's reliable, fast, and affordable in the real world? This is where some serious engineering discipline comes into play. Okay, so one of the biggest challenges is just keeping this map consistent. Imagine if on a world map, one city was represented by a giant dot and another by a tiny pinprick. It would be impossible to accurately measure the distance between them, right? Well, the exact same problem can happen with embeddings, and it can throw all of your comparisons way off.
And the answer, which is pretty brilliant, is something called normalization. What engineers do is they scale all the location markers, all the vectors, to be the exact same size. This makes the whole system more stable and predictable. It makes sure that when we compare 2 points, we're comparing their direction, their actual meaning, and not just their magnitude or how loud they are. It keeps all the comparisons totally fair.
Engineers also face this critical trade-off with the richness of the map, which we call the embedding dimension. You can think of it like this. A lower dimension is like a simple street map. It's fast to read, cheap to print, but you might miss a few subtle details. A higher dimension is like a super detailed 3D topographical map. It captures these incredibly rich distinctions, but it's much slower to work with and way more expensive to store. Choosing the right dimension is a total balancing act between speed, cost, and accuracy. So, after all this talk of maps and search strategies and engineering details, what's the big idea? What does it all really boil down to? Well, it comes down to one really simple but incredibly powerful concept.
The power of proximity. I just love this quote from our source material because it sums it all up perfectly. Embeddings are useful because they make the closeness of ideas something we can actually measure. That's it. That's the whole game. This is what lets modern search, recommendation systems, and AI go way, way beyond just matching words.
And look, this isn't just some abstract theory. This is the engine that's running under the hood of stuff we all use every single day. It's the tech that makes powerful AI techniques like retrieval augmented generation, or RAG, possible. It's the reason your streaming service can recommend a movie you'll actually love. This is really the foundation for AI that can finally start to truly understand us.
So, think about it. We have successfully managed to map the vast, complex universe of human language, turning something as abstract as meaning into something we can measure and search. And that leaves us with one kind of mind-blowing final thought to chew on. Now that we can do this for language, what universe of ideas will we map next?